Dear students, we are continuing with the same chapter, area. Earlier in this chapter, you studied about how to find out the area of regular figures. Regular figures, I mean figures which are having a definite shape and having a definite boundaries. For example, you studied about the formula to find out the area of square first, then of rectangle and triangles of different types, as well as that of parallelogram, then rhombus, and also how to find out the area of a trapezium. You are thorough with the formula of these different type of figures. Now here the question is how to find out area of figures having irregular shape. What is meant by irregular shape? A irregular shape can be a combination of all these coming together in a particular shape, or a completely irregular shape, like just like something the shape of a leaf or something which is around you. So in that case also, if we are asked to find out the area, what are the ways to find out the area of such figures? So before going ahead, you should be thorough with these different figures and the formula to find out it. And I am not going to repeat it because it is already repeated in the previous two video. You should watch that and come back here and continue with this so that you will be able to follow further, because those formula will be applicable here in order to find out the area of certain irregular figures. Certain irregular figures, you have to use certain other mechanism. Let me go ahead. Let us think about a irregular figure as given here. Here is a polygon A, B, C, D, E. Polygon is having a sense that a figure having an n number of sides. You studied about hexagon and octagon in the previous year also, and here we are having a polygon which we have divided into different regular shapes by drawing certain or doing some construction within that. When the name is A, B, C, D, means the polygon is originally A, B, C, D, E. That means this is the shape of the polygon. What we have done, or what is given in the question, is that we are asked to find out the area, and the polygon is divided into certain regular shape. This is a right angle triangle because there is a right angle over here, and this one is a trapezium because this side is parallel to this side, because trapezium is having opposite sides parallel. This side is not parallel with this side, but the other way, this side is parallel to this side, so it is a trapezium. Again, here is a right angled triangle. Here is another right angled triangle and one more right angled triangle. So we have the formula to find out the area of right angled triangle as well as that of trapezium. So we are in a position to find out the total area of this particular irregular figure with the help of adding the area of these different known figures like a triangle and trapezium. Let us do that first as a practice. How can we? Because this kind of figures are very common when we go for measuring the area of a piece of land, I would say. A piece of land means where we are going to do some cultivation, or we are going to make a small house over there. So the land will be of a shape, something which is like this. So what we will do is we will be dividing that land into known shapes. For example, if you simply draw a line here, this can be divided into 1, 2, 3 different triangles. Understood? Suppose the land is having a shape like this, then we will do one thing. We will consider making this into 2 triangles and solve the problem. So this kind of drawing within the given figure and converting that into known or figures like square, rectangle, triangle, trapezium, parallelogram, rhombus. These are some common technique used in measuring a piece of land. That's why this particular part is very important to you, because we come across such situation in our day-to-day life. So let us think about, it is given that it is given in meter. Find the area of the given figure. What I have to do is I have to first calculate the area of each of these figure, like triangle AQB, then that of triangle ERD, then that of trapezium AQRE, all separately, and find out the sum total of it. Let me do that. For example, if I start with the first triangle, let me name this as first, and write the triangle AQB. I'm going to find out the area of it. So in that case, the formula is very much known to you: half into base into height. As it is a right angle triangle, we can consider one of its side as base, other as height. It is given over here clearly how much it is, so we will be substituting that. It is 13 here, I forgot to copy it over here. So half into 10 into 13 is half into base into height. Then we will be calculating it as 65 square meter. That is the first figure which I marked. Think about this triangle. I'm taking the triangles together, which is equal to second triangle. We can say area of triangle ERD. In right angle triangle, always you should use the middle letter while aiming for that of 90-degree angle. So naturally the formula over here will be half into base, we can consider as 16, and that of 17. It is a product of the sides forming right angle, base into height, and products forming the sides. Product of the sides forming right angle are same in the case of a triangle. If you divide this, you will be getting 136 square meter. So we could get the area of the second figure which we considered. Now we can consider about trapezium, the third figure. I would say, let me mark 3 over here, and we will write the area of trapezium. The name of the trapezium is AQRE. Yes, okay. The formula is half into sum of the sides forming sum of the parallel sides AQ and ER. That means I should write 13 plus 17 into height. Height is the perpendicular side is this side, so naturally that will be the height, which is 12 plus 15, 27. 17 plus 30, luckily it is 20 plus 30, 30 and divided by 2 is 15, and total becomes 405 square meter. Let me consider the fourth figure over. So almost this is over. We are having figures like this over here. Instead of considering this remaining figure, that means this part, this part and this part separately, I am taking the whole triangle BCD together. So I have to write the area of triangle BCD, right, where we can consider from B to D as base, and here is a perpendicular drawn to the opposite vertex 10 as its height. So BD is equal to 10 plus 12 plus 15 plus 16, all measures are given here. When you add up the 10, 12, 15 plus 16, it becomes 53. So we will write is equal to, this is triangle BCD, area is equal to half into base over here is 53 and height is 10 meter, and we get the answer 265 square meter. So if we add all this, 65, 136, 405, 265. Altogether, we will be getting the area of the given figure, though it is neither a triangle nor a rectangle nor a trapezium. It's a combination of all. So this technique is very important, and it is quite mathematically true also, and very much applicable whenever we are having irregular shape which can be converted into regular shapes by construction inside or within it. And the best application in our day-to-day life or in our life is that whenever we measure the area of a piece of land, you should understand that whenever we are having construction at a site, even near you, even in a city or a village, when construction has to be made, first boundary to be made and the area to be calculated. So there will be a boundary wall and all, but inside how much area? For that we will be dividing that area into shapes which are very regular, and will calculate the area accordingly. Please understand. So this is one thing what is very important in the chapter. This will be the last video of the chapter. You should be very clear about that. Chapter is mainly about area. You came across area of square, rectangle, parallelogram, different types of triangle, rhombus, trapezium. Now here you got the combination of all these within a figure, a polygon, like where you may be having 5 sides or 6 sides or anything like that, but it's having a very good application. Let me move ahead. Next figure which you will be studying about finding out the area is area of a circle. When we talk about circle, circle is an entirely different type of figure. And I have told you earlier also, circle is having a lot of very special properties along with it. And when I told about circle, I told that it is having very close connection with the spherical earth itself. And you also know that when we study mathematics further, you will be studying about geometry, which will be talking about the measurement of earth and things on earth and what we made on earth, where you will be having a lot of application of circle. Just in the last class you studied, or last year also you studied about drawing perpendicular using arc, compass I mean. So in that case also a compass can create a or help you to draw perpendicular line. Why? Because we are considering the compass and the curvature and the circle as more accurate than any other kind of set square and protractor. Coming back to the area of a circle will be having its own area. I have colored the circle blue and marked the center of the circle in white. So this blue colored area is the circular area, and how much it is, that is the question. It doesn't have its own length, it doesn't have its own breadth, and such things are not applicable here. What we know about circle is about its center, its radius. Correct? Radius is the defining and designing factor of a circle. The length of the radius decides the identity of the circle, the size of the circle. So what I am going to do is, or what I have to tell you is about how to find out the area of a circle, or if we can develop a formula for it, because we develop a formula for all these figures like square, rectangle, triangle, parallelogram, rhombus and trapezium, and at last we have reached to another common figure, circle. What we are going to do is divide this circle into pieces, as many small pieces as possible. Your textbook has given 16 pieces. I would say that you will make it into 60 pieces. As small as possible, we will divide the circle into pieces and remove each piece out. I will show an example. I will just remove one piece out of this. That is my plan. Very small pieces are made. I will remove one small piece out of it, and will tell that you will remove all. This is the piece I am removing. I removed a piece from the circle. We know that this is a piece taken out from the circle, and it will be surely having a small curvature over here, but because as it is small we cannot feel it. That's what I said, we should have very smallest pieces of, and it looks like almost like a triangle with a small marginal curve over there, if I say. leave it like that, and we will consider that if you take this, and I am going to keep this piece over here, arrange it over here, and I'm going to take out all these pieces from here one after another and arrange it over here, one just close to the other, as many pieces possible like this. And when I look at this, it looks like almost like a parallelogram or a rectangle, right? Whether it is parallelogram or rectangle, we know that length into breadth is the area of rectangle, and base into height is the area of parallelogram. Height is the distance between these two. So if I can find out the area of this particular figure which I have obtained from the circle, the area of this particular figure will be equal to the area of this circle also, because I made a circle out of this. Now before that, I should go back and explain you what is here. These are radius, and we know about the perimeter or circumference of a circle. As far as circle is concerned, it is circumference. Circumference of a circle is calculated by the formula 2 pi r, that you know very well. So 2 pi r is the circumference. From here throughout, we will say that this is 2 pi r, which will give you the idea about the total circumference of the circle, right? And this circumference is having this base here, see, which we have removed. This is what is making the circumference. That we have kept here, right? Half comes over here, half comes over here. That means if I say this is the length of the rectangle, this length is equal to pi r, I would say, because this pi r and this pi r together constitute 2 pi r, which is the circumference. I repeat, we have removed these pieces from the circle, and the broad end of the circle altogether, broad end of this particular triangular shape altogether makes circumferences, and it is equal to, circumference is equal to 2 pi r. So it is divided equally here. If you have kept 40 pieces here, 40 pieces here also. So that means if it is 20 pieces here, 20 pieces here, that means 2 pi r is divided into pi r and pi r here. And what is this distance between these two? At any point, if you calculate, it is, we know that it is equal to the distance from center to the circle, and which is equal to r. So if I apply the formula of how to calculate the area of this rectangle, or even if it is parallelogram, we can say that length is equal to length into breadth is length in this case is equal to pi r, and breadth is equal to r, and the formula becomes pi r square. My dear students, this is what is the most important information I want to transfer to you. The area of the rectangle is pi r square in this case, and that is the area of the circle. And pi is a constant and r is a property of the circle, and you can apply this formula to calculate the area of a circle, and pi is having a value 22 upon 7, you know, otherwise 3.14 approximately. That means you could develop the formula to calculate the area of a circle, my dear students. It is equal to pi r square. Circumference is 2 pi r, and the area is pi r square. Apply this wherever, in whatever format it is asked, you can solve the sum. Area of a circular ground is 3850 square meter. Find the radius of the circular ground. So what is given over here is area of the ground. Area, what kind of ground it is? Area of the circular ground. It is equal to 3850 square meter, right? So we know the formula of area of circle. Area of circle 3850 is equal to pi r square. So that is what is given. So we will be writing, instead of pi, we will be writing 22 upon 7, and r square we will calculate, because we are asked to find out the area. R square is equal to 7 into 3850 upon 22. we have to divide 3850 with 22. Understood? And when we divide this with 22, what you will be getting? You will be getting r square. And on solving it, you will be getting 1225. If you solve this, you will be getting 1225. Okay, my dear students, this way we will be solving sums related to area simply by applying the formula. Okay, we'll go ahead. What is this? You studied about now how can we calculate the area of different figures like square, rectangle, triangle, trapezium, circle now, and even if they are a combination of all these having a different polygon also. But there will be certain situation where we cannot calculate because the shape is such that we have to go for approximation. What is that situation and what is this approximation? That is what you are going to learn now. Approximation becomes a necessity for us because we cannot convert the given figure into or convert that or divide them into a regular figure. For example, suppose the figure is like this. You are asked to find out the area of this figure. You cannot convert this into neither as triangle, rectangle, parallelogram, square, or compass or circle or nothing like that. So you will be forced to do some approximation. Approximation means is having a sense that somewhat near, close by area. Suppose that if you can make small squares in this having defined size, we can simply find out the area of it. For that we need to draw squares in that. So there is a technique for that. You can use graph paper or something like that so that you can draw this figure inside the graph paper or make grids in this way. जैसे अभी एक grids बनाया है, and if this is having size equal to 1 centimeter on side, so this is a 1 centimeter square it is. So you can find out that approximately how many full squares are there. You can find out that is 1 over here, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can count like this: 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. I'm taking this square also. 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. I'm taking this also. 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62 तो guarantee है. Okay, so 62 is sure for me. So I will write minimum 62 square centimeter. Is it correct? We are approximating. Now let us consider those figures, those particular squares having more than half. In that this will come, I will say 1 over here, 2, this is having more than half, 3, 4, which I have not counted, 5, 6, this is also having more than half, 7, 8, this is not there, 9, 10, 11, 12, this is not there, 13, 14, 15, 16, 17 figures are there which are having almost more than half of the area is of that of given figure. So half square centimeter से होने ज़्यादा होने की वजह से we will consider that also as full, and what we will do, less than half square we will leave it aside. So we can add this and say that approximately 62 plus 7 69 plus 10 79 square centimeter is approximate area of the given figure. This is called approximation method, because we did not consider those figures having less than half square centimeter. We considered it as 0, and half exactly is also not there. So more than half we have taken into consideration, and we have made it right. Approximation is done. This is approximation because it cannot be accurate. So this is a way by which we can calculate the area of irregular figure by approximation. You need to convert that into a figure on a paper having grids or graph paper like situation. So my dear student, that's what is in the video, and that topic area is completing. I have provided you 3 videos. 3 videos will be sufficient for you to understand the concept. Maths is all about understanding the concept, then practicing it. Understanding is first part, that's over. Practicing you have to do. For that you should answer the questions given in the test. So very few questions are there, just not sufficient for your practice, but you should do that so that you will be confident enough to apply this whenever, apply the formula of different type of figures and its area whenever time comes, and practice makes you perfect. Thank you.